Alright, so as you can see up here, I have written the generic equation of state. So you'll recognize that this looks similar to the van der Waals equation of state that I showed you earlier. But the difference is that we've got this sigma b term, or this epsilon b term, and this sigma b term. Those are in this equation because in the van der Waals equation, sigma and epsilon are both equal to 0, so that's why they're not written in the van der Waals equation. But there are other equations of state out there that have different values for epsilon and sigma. So we write it in here when we're just talking about a generic equation of state and not a specific one. So I also have the compressibility factor written out again. And then I've got two other equations that relate beta and q, which are two new letters that we're introducing here, to some other values that we will get to later. But we become clear why we may need them. And it's basically just to simplify things and make it look a little nicer because we will get some pretty ugly fractions going here. So our goal for this problem is to get this generic equation of state into a cubic form related to the compressibility factor. So we want a cubic form of the compressibility factor. So we need, a z cubed term, a z squared term, a z term, and a constant term equal to 0. So that's the form that we're trying to get this into eventually. But we're starting with this. So starting with this doesn't have any z's in it. So first thing we're going to want to do is put some z's in it. So, okay. So compressibility factor is pressure times volume over gas constant times temperature. So we've got a pressure up here, so let's just multiply this whole thing by specific volume over gas constant times temperature. Because then that will give us a z on the left-hand side, which will be helpful. So let's do that. So we've got pressure times specific volume over RT is equal to, so in this term, RTs will cancel, so we'll just be left with specific volume over specific volume minus B, and then minus, so we'll have A times specific volume over gas constant times temperature times specific volume plus epsilon B times specific volume plus sigma B. So you notice that these two terms kind of have a similar form to them. And we're going to try to keep these two terms having a similar form throughout most of this problem, just because it's nicer that they look the same. Okay, so next thing we're going to want to do is we're going to want to multiply everything over here by the form of 1, which is 1 over specific volume times 1 over specific volume. This will just make it easier to see what we want to do next. And we can sub this out for the compressibility factor. So we've got compressibility factor is equal to, alright, so 1 over v times v, that's just 1 over. Alright, so that over v is 1 minus v over specific volume minus, so a times v over v, that's just a. Okay, and then we get, okay, so we'll keep RT here. So this is where I was saying we're going to want to keep these two terms kind of the same. So we can take one of these and divide it by b. So we'll take the first one and divide it by b. So that's just going to be 1 plus epsilon b over v. So over the specific volume. But we're going to want to keep this one kind of the same. So we're going to factor out that b and put it outside. So that it will be 1 plus sigma b over specific volume. Alright, okay, so next thing we're going to want to do is we're we're going to want to get some more z's in there because we are going to end up needing z cubed, z squared, stuff like that. Right now we've only got a single z. So what we're going to do is, we've got lots of b's. So let's solve this over here for b. So that would be b is equal to pressure Z times gas constant times temperature over the pressure. So you're going to have to plug this in everywhere that we see V up here. So we're going to get Z is equal to 1 over 1 minus B over, okay, so there's a V, so we're going to have P up top, and then Z times gas constant times temperature, and then minus, alright, so here I'm going to kind of separate out these two terms to make it easier to see. So we're going to have big parentheses, and we're going to have A over, so then we've got a V, so that means we'll have a P up here, and then over Z, R squared, T squared, is the RT times the RT over here, we'll square, and then, no parentheses yet, and times 1 over 1 plus epsilon B over, so we've got another V, so again, plug that in, so we can, for pressure over Z times gas constant times temperature plus, not plus, times 1 plus sigma B. So same deal, so we'll plug in the V. So we'll get times the pressure over the compressibility factor times gas constant times temperature. Alright, so now this is where it starts looking a little gross. And we're going to want to use these down here. So you'll notice that beta is equal to B times the pressure over the gas constant times T. And we can see that lots of places in our equation. We've got it here, we've got it here, we've got it here. So let's just switch all those out for beta so that it looks nicer. So we've got Z is equal to 1 over 1 minus. So switch out this for beta, and we just got beta over Z minus A times the pressure over compressibility factor times gas constant squared times temperature squared times 1 over 1 plus epsilon. So again, we're going to switch that out, so it's epsilon times beta over Z, and then 1 plus sigma beta over Z. So that just cleans it up a little bit, makes it look a lot nicer. So we're going to end up wanting all of our Z's, to be on the same side, so we might as well go ahead and divide everything by Z. Or in other words, multiply everything by 1 over Z. So that will get us a 1 on this side, and then a 1 over 1. So then we'll multiply Z by this bottom. So we'll have Z minus beta minus, so we're going to take, okay, so this is where we're going to want to make sure we keep these two the same. So we'll have this A, P over R squared, T squared, like normal. But then we're going to take this Z and multiply it by the first term, and take this Z, multiply it by the second one, so we have the same structure in these two terms. So what's that going to look like? So we'll have this Z times that, so we'll get Z plus sigma times beta, and then we'll take this Z times that, so we'll get compressibility factor plus sigma times beta. All right. So next, you'll notice that this term is still looking a little clunky, and we haven't used this q at all yet. So we can just come over here and split this up and see if we can make it a q. So I'm going to come over here in pink so it's different and stands out. So I'll have A times P over gas constant squared times temperature squared, so that's just this term right here, over here. And then, so we have Q is equal to A over B times R times T. So we're close. We can get the A over the gas constant times the temperature. We do not have the B though. And that will leave us with the pressure times over the gas constant times the temperature. And you'll notice that this looks an awful lot like beta. But again, without this B term. So that's okay. We can just rearrange this equation for what we have. Move the B's over. So then this, we multiply the B, so then this just becomes Q times B times, and then we divide the B on this side, so we'll get beta over B, and then these will cancel, and we'll just be left with Q beta. So Q beta can be plugged in for this, which is quite a bit nicer. So let's do that. So we've got 1 equal to 1 over Z minus beta minus, okay, and then now I'm going to combine these terms back up. I'm going to split them up so that you can see that this term was its own thing. So then we'll combine those back up, so we'll get Q beta over Z plus epsilon beta times Z plus sigma times beta. Alright, so now what we really want to do is get rid of these fractions. We don't want to be dealing with a lot of fractions. So we need to find a common denominator. And to do that, we're going to multiply the whole thing by Z minus B, Z plus epsilon beta. No, this is a beta, not a B, sorry. Plus compressibility factor plus sigma times beta. So that's going to be our common denominator that we're going to multiply everything by. So let's write that out. So we've got all of that times 1, so it's just itself. So we've got compressibility factor minus beta times compressibility factor plus sigma times beta plus times compressibility factor plus sigma. No, this is, okay, so epsilon times beta, sigma times beta. Okay, and then for this side of the equation, the Z minus beta will cancel, and we'll be left with these two terms. So we'll just have Z plus epsilon beta times compressibility factor plus sigma beta. And then for this one, we'll have the minus sign. And then these two terms will cancel, so we'll just be left with this one and that. So minus Q times beta times compressibility factor minus beta. Alright, so we've got that, and now we're just gonna distribute everything in combined like terms, and then we should get a cubic polynomial because we've got a Z times a Z times a Z. So just a little bit of algebra, and then we'll be good to go. So for this, I'm going to use different colors because it's going to be easier to see. So let me get those set up. Alright. So I'm going to use different colors to represent each, Z term. So Z cubed is going to be purple, Z squared is going to be blue, Z is going to be pink, and then our constant is going to be orange. Okay. So on this side, we're going to multiply these two first. All right, so let's start with these two terms right here. We're going to multiply those out. So one is going to be our z squared term. So we're going to have z squared just by itself. Pink is going to be our z term, so we'll have, okay, and then I'm going to use black for the operations between the two. So then we'll have z times that, and then z times that, so we'll have z times epsilon beta plus sigma beta. And then for our constant term, we're going to have epsilon beta times sigma beta, so we're going to have epsilon sigma beta squared. And this whole thing is going to be multiplied by this term, which is compressibility factor minus beta. All right, and then for this side of the equation, we've got, all right, so then these two terms were the same as these two terms that we multiplied, so I'm just going to rewrite that as is. So we'll have compressibility factor squared plus compressibility factor times epsilon times beta plus sigma times beta plus epsilon sigma beta squared. Okay? And then we're going to look at this term. So we're going to have minus, and these are going to be constants. So use this color, so it's negative q beta times compressibility factor. Oh wait, that's not a constant. Sorry, because z is, that's just a z term, so you can use pink for that, so it's going to be q times beta times compressibility factor. Right, and then minus times a minus is a plus. And so we're going to have plus, this one's going to be our constant, so q and beta squared. All right, so we're getting somewhere. Now we just need to combine these terms, combine the same colors over here. All right, so now we're going to have a z cubed term. So we're going to have z times z squared, so we're going to end up with z cubed. And then, all right, so let's work on the z squared term next. Z squared, so I have z squared times negative beta, and then we're going to have z times this, so we'll have plus epsilon beta plus sigma beta. Alright, and then we'll have our single z term, so we're going to have z times, so negative beta times that, so we'll have negative epsilon beta squared minus sigma beta squared. And then, well, not done with the z term yet, so then we'll have z times that, so we'll add epsilon sigma beta squared. Alright, and then now we just have our constant term left, which is going to be negative, because it's a negative times a positive, so it's going to be negative minus, so beta will be cubed, so it will be epsilon sigma beta cubed. Alright, so now we've factored, or distributed out that side of this equation. Now let's combine some like terms on this side of the equation. So our z squared is just z squared, and so in terms, we'll have compressibility factor times epsilon beta plus cubed times beta. And then for our constant terms, we will have epsilon sigma beta squared plus q beta squared. Alright, fix this. Okay. Alright, so we're almost there. We just now need to get everything onto the same side. So, again, we'll start with our z cubed term. So, that's just z cubed, and then I have one of those. And then add that to compressibility factor squared times, okay, so coefficient for this one is going to be this plus 1, because we're going to have one of those over here. So negative beta plus epsilon beta plus sigma beta, oh, not plus though, but we're going to subtract it from the side over here, so minus 1. Alright. Next, for our single compressibility factor. So this one, we're going to combine this term and this term. So we're going to have these ones first. So we'll have negative epsilon beta squared minus sigma beta squared plus epsilon sigma beta squared. Okay, and then subtract all of these. So it's minus epsilon beta minus sigma beta plus q beta. Alright. And then finally, we have our constant term. That's going to be plus, and we'll combine all of these. This will be plus negative epsilon sigma beta cubed minus epsilon sigma beta squared minus q times beta squared. And all of that is going to be equal to 0. So there you have a cubic equation of the generic equation of state in terms of the compressibility factor.